Okay. All right. Mic looks good. Okay. All right, so hopefully that last interval was at least interesting. Illuminating would be great, but interesting I'll settle for. At the very least, that should inform or at least give a little bit more background to the lab that you guys did last week. I know I kind of threw the Arduino stuff at you, but hopefully you've had a little bit more time to immerse yourself. You know what's going on, you're more comfortable and familiar with the vocabulary, all that good stuff. Back in PLC land, I'm going to throw a new language at you. So, come on. This language that I'm going to teach you is right alongside structured text and ladder logic, ladder diagram in the bubble selector, right? When we make a new program and we can select which program to use, this is one of those selections. After today, there will only be one language that I haven't told you, but the last language is more useful for like archetyping whole systems, really like PLCs controlling other PLCs. So like if there was a 300 level to this class, that's probably when I would teach that language. But for most things, you know, of the practical nature, they can be handled with one or more, you know, of the other languages that I've already taught you. So this latest one is kind of similar to ladder logic. It's kind of like ladder logic's hipper, more feature-packed younger brother, okay? It is in a visual style, okay? It is a visual programming language, meaning that we're wiring elements together. We have variables that are, you know, contained in tags that we can wire into places, similar to, for example, timer blocks. So the timer block in our ladder logic, I would consider to be kind of like a functional block thing. It really, like traditional ladder logic didn't have blocks like that, outside of like set blocks, for example. Okay, but function block, that's its whole thing, is blocks. We no longer have ands and ors, for example, with our ladder logic. You know, you could recall that to do an or, an and, you know, looked like this, and an or looked like this, okay, for ladder logic. But for function block is we have an and block. Okay, sometimes it'll say and, sometimes it'll have the ampersand, okay, but it'll have a block, and then it'll have, you know, one input that you can wire in and another input that you can wire in, and then it'll have one output. That is the result of that logical function, okay? In older versions of a function block diagram, they had the Boolean operator on it. That looks like this. And for or, looks like that, okay? This is the and symbol, and this is the or symbol, okay? And this one also has an out and has two ins, okay? So this would be, you know, in, out, and same for our blocks. And then our program is just wiring one block into another block from left to right to do all the operations that we want to do. And at the end of the day, at the right, you know, would probably be our output that is attached to like a relay, for example, where all of our operations would wire into that relay, and whether or not there's a 0 or a 1 on that wire would turn on or off the relay accordingly, okay? It's worth noting that the information that's contained on this wire is data type dependent, okay? The data on this wire could be, you know, binary, high or low, 0 or 1. It could be analog, right, between 0 and 1024, I believe it was. Or it could be a number, right, an integer between 0 and 35535, right? That is just some number on there that we're doing math on. There's math blocks too. There's multiply and average. That's kind of where the power of the block starts to come in, because can you imagine trying to do a simple average with like Boolean operations and doing math and stuff? That's crazy. But what if you just had a mean block or an average block that you could just wire into. That's awesome, right? That's super useful, time saving. It's easy to tell what you're looking at. You know, data goes in one side and it comes out averaged on the other. That's great, that's awesome. That is the real strength of this language, is that it handles a lot of heavy lifting in these functional blocks of ours, okay? And when you get really advanced with it, you could kind of make like networks and networks where a whole function block ladder could be held within one block, okay? And you start to have like recursive systems, okay? It can get intense. You can have blocks that call structured text code and structured text code that calls blocks, okay? This is really where that system architecture, right, programming architecture starts to come into the works, where you could break up, if you have a really complicated program, you could, you know, do like the sensor processing in one thing and then the, you know, program logic in another thing, the IO in another thing, and whatever, you know, whatever gets the job done best, the tools for the job. Each of our languages has strengths and weaknesses to it, okay? And I'm gonna make that apparent in a following slide, okay? So again, the components of this system is not code like structured text or contacts and coils like ladder logic or ladder diagram, but wires and blocks, okay? So in older systems, you would get really simple blocks. You would have, you know, Boolean operators like AND, OR, NAND, XOR, that good stuff. We have a good old timer block, our T on and T off that you guys are familiar with from using already. And then we kind of have older school blocks like this, reset set block. Okay, so here we have the set bit, where if this goes high, then this will output high, and it will always output high forevermore. It latches on unless we click on to its reset pin. If this goes high, then this unlatches back down to low, and that's a useful thing to have as well, you know, depending on the logic that you're trying to do in your program, storing the state of a bit or clearing an alarm, or, you know, whatever is a useful thing. So in the modern day, our UIs look a little prettier. This is another example of a visual programming language. Visual programming languages are very popular in art programs. So things like Blender or Maya or you know, lots of things with animation will have this wiring and block diagram where you wire data in, and then you can have really complex operations happening. So for example, photo editing, okay, can be done in this way, where you have like a block that your raw photo data comes in the left, and then you have a block to change contrast and a block to change saturation and whatever. And at the end of it, your output is, you know, an image object, and the thing traveling through the wires was an image the whole time, and being operated on was an image. But for us, the data type, again, is tightly controlled in our variables. You know, are we dealing with a Boolean? Are we dealing with an integer? I'll call this like analog input. Are we dealing with an integer or what have you? Okay, float, L-real, all that good stuff. And just like before, hunting up these blocks is a relatively simple action of running through the catalog. Okay, because just like structured text, or sorry, like ladder logic, where you could hunt down that T on and T off block, the average block and the multiply block and divide block and all the blocks will be in a selector within your program. So if you'd like to go into your PLC IDE right now and create a new program, create a new function block diagram program. All right, and then I want you to go into your toolbar. I think it's in your view menu. And I want you to make sure that your FBD toolbar is visible. Okay, that will be a whole bunch of on-screen icons that you can click and drag and use. That will be very useful. Okay, and we'll get into some of those operations in a second, some of those function blocks. I have some placeholder text on this slide, don't mind that. Irrelevant Arduino text. Oh, so that's the FBD toolbar? Is that what you're talking about? Yeah. So it should be pre-populated. Is it blank? Can you press the FBD toolbar?
This one? Or this one?
Oh, no, sorry. It was like, it'll be up here, view, or window, FBD bar.
Tool window?
Toolbars. FBD bar. Hey guys, it's view, toolbars, FBD bar. So you should have a whole bunch of new icons, right? Awesome. Yeah, for sure. So that's your palette, right? That's all your tools. Anyone need help getting that toolbar up? Okay. All right, so now I want you to poke around with those blocks. I want you to drag them into your program, try to wire them up. And while you do that, I'm going to drone at you on what each of these functions are. Okay, so we've already gone over the first two. We've gone over the AND block, quintessential, as well as the OR block, okay, bread and butter right there, as well as your timing blocks, T on and T off, and they work exactly the same. Okay, up here, it's using a different program, so time is represented differently. In some PLCs, time is like its own variable type. That it's like a mixture of minutes and seconds. It's weird. For us, it's just milliseconds, okay? It's thousands of milliseconds for seconds, whatever. You wire that in as a variable, as an integer data type, right, into our PT point, okay? As compared to structured, or I keep saying structured text to ladder logic, we might also have some extra flags available to us, okay, that give us additional information. So not only do we have our output that goes on or off after a certain amount of time based on our timer, but we might also wish to query the time elapsed. Okay, so it's doing some timekeeping. How long has this timer been running? How long until we need to do this other thing? Might be useful information to know. Okay, one that we haven't really gone over much before is the idea of the NOT operator. Okay, the NOT operator as a Boolean symbol looks like this. It looks like an OR with one leg that has a circle at the end of it, just like that. Okay, what that means is that we invert anything going into it. So if a 0 is going in, a 1 is going out. If a 1 is going in, then a 0 is going out. It reverses everything going into it, okay? In function block diagram, we also have a block that does that, okay? So if we have the wrong output, if whatever is happening on our PLC is the opposite of what we want to happen, we could just throw a NOT block on there and bang on, we're right as rain, right? It suddenly has the exact right output. Very useful. TP, I believe, is a pulse. So at the end of that elapsed time, it'll set a pulse. It's useful for setting things with our RS or SR blocks. Okay, and now we also have basic math functions. We haven't had that before for this kind of visual programming language. We had that with structured text a little bit. All right, but now we can do things as we go through the loop. Okay, so keeping track of averages is really useful when it comes to sensors. If something's drifting over time or if something's really noisy, we might want to cut down on that noise by sampling it many times. Okay, this basic math could be used, for example, getting our analog 0 to 1024, turning that into a readable Celsius or Fahrenheit value could be done with these math blocks. Right, that's just one way that you could get human readable or at least human workable variables in the mix. Okay, so we have adding blocks and dividing blocks. We have remainders or subtraction blocks, right? Multiplying And I'm not exactly sure what the move block does. That might be a bit shifter. This is just an example I got offline. But if you're interested, down here, these are the Boolean symbols, the Boolean logic I was talking about. Okay, so an AND kind of looks like a letter D with 2 inputs on the left and 1 output on the right. An OR is often this kind of rounded shape or a triangle, as I drew it. Okay, NOR, or a inverted or not OR, is the same symbol with a dot at the end of it, just like the not symbol is. Okay. All right, and then XOR, exclusive OR. You can only have one or the other, not both, for it to be true. Looks like that, and those are also all blocks. Okay. Something to note is that an OR symbol and a NOR symbol sometimes look strange. Okay, the AND is self-explanatory. It just looks like an ampersand. But on some programs, for some godforsaken reason, they chose this as their symbol for OR. I do not know why, but that is the OR block. Let it be known. Okay. Basic building blocks along with the rest of the stuff on your palette. Okay. So I referred to this before a little bit is, what are the strengths and weaknesses? We now know 3 different PLC languages, 4 including Arduino, which I do include. Okay. But you really, at the end of the day, have the choice for whichever one, but you have to consider your audience, who's going to be fixing the thing, what languages do they know? The complexity, the task, right, is like how difficult is it? How reliable does it need to be? You need to, are you doing math or not? Can you handle it with a simple ladder diagram, or do you really need to pull out the advanced structured text or function block diagram for it? Okay. But at the end of the day, just remember the PLC is a black box. If someone can read the software, maintain it, and the black box does what it needs to do, 9 times out of 10, 99 times out of 100, okay, that'll be just enough to get by, okay? So again, there is one that we haven't gone over yet, which is sequential function chart. It almost looks like a waterfall diagram. You're more than welcome to look into it and to use it. The PLC does support it. Okay, again, it's just an educational tool that it supports all of these languages. But that one is outside of the scope of this particular class. Okay, and that's it. That's part 2. You now know all the languages that I wish to teach you for this course, or at least the basics of it. Okay, so we are going to be doing only one more lab. Actually, no. Next week is catch-up lab, right? Week 7? Week 8. This is week 7, so we will have one more lab this week, and then afterwards will be a catch-up lab, okay? So it is going to be an Arduino-related lab, so I recommend, again, you guys look up some more videos, do some more tutorials. There are so many tutorials for Arduino. Look at 1, look at 2, in between this time and our lab time. Anything else, let me know. Otherwise, feel free to use the remaining 12 minutes, 11 minutes for your lab. I'll be around.
Does the ID software work at home too? Does the Arduino programming software work at home too?
It does, yeah.
It does? Okay.
So that's free. It's easy to download. The blue one, right? The blue software, yeah.
It won't give any errors though, because some makes you go into like we can do the, what's it called, the
Compile.
debug stuff, right?
Well, Arduino doesn't have live debug. That's a PLC thing.
All right.
It has like a message box that you can print to. Is the closest thing it has.
That's
Yeah.
what I was saying. Yeah, sorry. I'm getting my softwares mixed up.
Gotcha.
With the message box, though, you have to write in your code like serial print it
Yes.
to get it to work.
Correct, yeah.
So you have to kind of make it yourself.
Yeah.
Exactly, yeah. That's exactly right. And why live debug is so cool, because you don't have to do that.
Yeah.
Yeah.
It's very convenient.
Right?
literally just double clicking, setting it to, forcing it to false or true.
Yeah.
Nice. Yeah, very convenient.
Alright. I need to go like reset something, test.